Good morning. I'm here this morning with Bruno Belanger of BCom Testing. And one of the things we'd like to do is take a few minutes and talk about some of the different ASTM standards and the strain gauges that are typically suggested for use with these standards. And we'd like to start with the tension test. And what I'd like to start with is the ASTM D 3039. So, Bruno, what can you tell me about that test?
Well, good morning, Daryl. D3039 is basically the tension test for a composite material. In the past, for many years prior to D3039, people used to use D638, which is a plastic tensile test. The reason being why the consensus was to change from D638 to D3039 is the specimens were not necessarily designed to do composite testing. If you look at the D3039, it's not a dog bone specimen, but a rectangular specimen. And the reason for that is since we're dealing with fibers, we're cutting through the fibers and affecting the performance of the composite. And also the speed of testing was quite dramatically different between the two. D638, for example, you could be testing at 0.2 inches per minute, while for D3039, you'll be testing at 0.05 inches a minute.
So a much slower rate of test, right?
It's a much lower rate because you don't deal with a very viscoelastic product per se. It's a more rigid system.
So more for metals then?
The 3039 is more in line with the fact that you have to engage the fibers and things like that. It's closer to metal, but it's not. It's actually slower than metal.
Okay.
So plastic is being the very viscoelastic product. Then you get towards a metal that has some viscoelasticity past the elastic portion of the curve. And then you get with composite where there's very little viscoelastic most of the time, section because you're engaging fibers. And when the fiber breaks, everything basically collapses or get damaged. So for tension, that's the main two differences that you see for composite and plastics versus every other materials that you have out there.
And as far as the gauge selection goes, it looks like we gravitate toward a 250 size strain gauge, which means it has a 1/4 of an inch active length. And that sounds like that must be pretty typical for these.
The first thing in general for all composite testing, one of the things that's very critical with any plastics or composite, we're dealing with a lot of insulating materials. So a 350 ohm is a must on all the tests. 120 ohm is not very suited for composite testing, and the ASTM does not recommend it. The 250, like you were saying, Daryl, you're correct when you say the 250 size gauge is a quarter size grid on the actual strain gauge is recommended. We can get by in some cases with a 125 size. So basically, like you were talking about, Daryl, the 250 size gauge is recommended for most composite testing when the coupon size actually warrants it. In some cases, there's ways that you can actually be able to use a 125, which is an 1/8 of an inch grid. One of the issue with those could be related to the size of the fibers or the size of the actual pattern of fibers. So, but for the most part, you can use a 250, and usually that's the best way to do it.
Okay, fantastic. So we've taken a look at the tension 3039 and briefly the 638, and we'll go ahead and move on to some of the other test methods.
So basically, also if we go back to tension for just a minute, and we look at tension, fatigue, everything we just said about the D3039 does apply to fatigue. The difference is the type of gauge you're going to use for that. You're not going to use a CEA or an EA type gauge. You would go towards more WK type gauge. Still using a 250.
And WKs because they have a better fatigue life.
Correct. Especially in this case, when you do tension, fatigue for composite, a lot of times you're going to go to 50% the yield value or 50% rupture value of the actual composite. A CEA will not survive these type of loading for a very long period of cycles. So WK is a more suitable candidate.
And the tension fatigue is D3439?
3479.
3479. Okay. Yeah. So same basic size of strain gauge, just a different construction so that it lasts longer in that fatigue environment.
Correct.
Okay. Great.
Also, if we look, let's say, at the shear type test that we have out there for the ASTM, we have different versions of them. Some of them are done in tension, like D3518 or D7078. And also for 4255 can be done in tension and compression. And then you have compression type tests where, like, the D5379 is basically cantilever type testing.
Okay.
So what you're doing there is double V-notch type testing. And what you get out of D5379 and D7078, or basically like we talked about your previous podcast, was that we have actual notches to force the actual shear pattern to happen between the notches. There are two different type of tests in a way that D5379 is a cantilever type pushing down the specimen, while the 7078 is a bigger specimen. It's really looking like a bow tie with a bigger gauge in the middle, and you're really trying to shear it in tension. So you're pulling and try to rip the other direction versus being cantilever on one side. 3518 is a tension type test, and it's usually used when we have 45-degree orientation fabric. The reason for that is you basically leave the fabric or the fibers at 45 degrees, and you pull it in tension to actually have the shear value as the fabric's trying to rotate. You're creating a shear pattern within the specimen.
Yeah, so for that one too, I think we recommend some pretty basic 250 size gauges and a T-rosette geometry.
Yeah, T-rosette geometry. You can use the UV patterns. You'll see those used in a 4255, which is basically a 2-rail or 3-rail system where you actually, same thing here, you attach two sides to that coupon and you're really trying to rip it in between the two rails. And then with you creating a rotation, which is a shear basically in this case. And so the 4255, in our case here in our lab, we use the 187 UV. You can use a WT, all the stack rosette the same way. It really is a function of what you're trying to achieve. If you're just looking for the shear modulus in that direction, the direction you're pulling, then like a 187 UV will work. But in a lot of cases, again, the ASTM is very specific. Stay within 350 ohm, and sometimes you can go to 500 ohms. Like if you see with the Yoshi Pescu 5379, this is a 500 ohm gauge that's designed by Micromeasurement to do the test. It's a much better. It covers the whole area, and if you want to read more about it, I know Bob Watson had a presentation at Micromeasurement about it, where you'll see that if you use an actual shear pattern like an 062 UV, you will actually not get the whole spectrum of where the strain field is through that specimen. So unless you have a correction factor for these gauges versus reality, you're underestimating what the modulus is in reality.
Okay.
So this is pretty much in a nutshell what the shear would be. There's a lot of different gauges, and we have compiled a table, and I believe if it's not on the website, it might be available soon on the website, related to these. Also, when you look at composite testing, we have tension, shear, then there's compression, flexural, and we talked about a little bit about fatigue. In the compression mode, for many years, a lot of times people were using displacement of the crosshead for modulus calculation. One of the issues with that is, although your crosshead could be extremely precise, you're not engaging the fibers or the coupons, and you have a lot of, call it slack, between the fixture and the actual touching of the coupon, and you're not really engaging the fibers immediately or a certain time. So depending where you pick your modulus with a crosshead displacement, you could be off easily by 50% in some cases.
Wow.
So depending on the fiber orientation and all that, it's very critical to use a strain gauge for those tests. And you'll see a lot of people or a lot of labs or a lot of companies will report on compressive strength. The reason for that is you have to add a gauge to have the modulus, and if you don't want to report the modulus, you're only going to see strength. So there's been over the years several methods that's been proposed or used to actually incorporate the strain gauge in it. The first one that was looked at is D695, and it was modified by Boeing back in the day to incorporate in the fixturing a little slotted area to actually install the gauge in that area. One of the issues with compression, usually you have to have a support system. Mm-hmm. And if you don't have a support system, you're creating buckling, you don't have true value of your modulus. With these fixtures for D3410 or D6641, there's potential for buckling, but a lot of times they're sufficiently supported that you will have a pretty accurate value for modulus. But it's very critical that you do use strain gauges for those.
And I think we came up recently with a new design strain gauge for D695.
Correct.
It's a CEA gauge that has the tabs off to the side so that it would exit the fixture more easily.
Yeah, one of the issues in the past with doing the compression test is the tabs were always located in the direction of testing. And if you've seen some of these coupons that have tabs on them that basically reinforce the area where we're gripping on the specimen, you'll find out that there's not much room. In some cases, we only have ½ inch to actually put the gauge in that area. Mm-hmm. And the gauge, for all intensive purposes, with the tab and all that, is close to ½ inch. So by the time you put it in there and try to solder the wire in there, it's a very complicated, and you put a lot of pressure on the gauge and putting a lot of weight on the tab. By rotating the actual grid and moving the tab to the side, then all of that is a lot easier to install. I believe it's provide better accurate data because it's more repeatable. It's easier to install, so you do a better job in the install process. And also, I believe that way also we can use what the ASTM call for, which is usually a 125 size gauge for these type tests. You can use a No 62 as well. We've done it in some cases. And again, it's limited. The limitations are usually related to the size of the fibers you're dealing with. Your gauge cannot be smaller than the width of the strain of glass or carbon or anything that you have in your composite. Otherwise, you're not reading properly what the composite is doing.
How does D695 compare to 3410 and 6641? Like, when would you pick one versus another? Like
the 695 originally it was designed for plastic, so it was a typical migration like the D638 for tension, where people started with that, and the coupon for D695 is actually looked like a small dog bone. The same type of issues that you could see 695 and you would see 638 for a composite is the fact that you were basically machining fibers out, and it's not a rectangular specimen.
I see.
So the D3410 is mainly used for very uniaxial type fibers, or you could use it for anything really, but it gives you better accurate data for like a 0 degree orientation, unidirectional type fabric. Same thing with the 6641. Can you test it with 695? Yes. Are you losing some precision? Probably. And the only way to get around in 695 is to tab the specimen. And a lot of times when you're dealing with a very oriented fabrics, there could be several layers of them. D3410 and 6641 have to be tabbed.
Okay.
So it's a question of, it's not preference per se, but it's more about what is your material, what you need to read, and how accurate do you have to be. Are you just doing a spot check of the material to make sure it's okay, and you have data based on the last 10 years? Or you're using this for FEA purposes and you want to really have accurate data measurement. So at that point, I would probably gear towards 6641 or 3410. 695, like I said, has been modified over the years because a lot of people already have fixturing and all that, and it's not a complicated test to run. It's kind of an easy thing to do. The last, not least, of the 5 major type tests you can run will be flexural. In flexural testing, strain gauges is not necessarily where you see it the most. Main reason for that, again, is...
When I see flexural, I start thinking bending. like
Yes.
cantilevered assemblies?
It's usually like 3-point, 4-point bending.
3-point, 4-point bend. Okay.
So we're not looking necessarily at cantilever type beam. We're looking more at two support at the bottom, a loading
Gotcha.
nose on the top, or two loading nose on the top.
Gotcha.
The reason why in flexural, there are several cases where we use strain gauge base transducer to measure it, like a deflectometer, that we would literally put underneath the specimen. One of the issues you got sometimes with putting a strain gauge in composite testing for flexural tests is you get buckling issues or tension issues right at the loading nose area. So you cannot put the strain gauge where the loading nose is, so you would have to put it on the opposite. And a lot of times you'll have premature breakage of the surface of the fibers, which will, unless you're really measuring really on a short section of the flexural part, it's usually easier to put a deflectometer underneath there. Less danger for breakage or, bad readings. So it's possible to use it. We've used it. Again, same thing there. You use a 250 size gauge. You want to be very well positioned because that's very critical as far as where you're going to be on that. And usually that's where sometimes things get a little bit complicated because let's say we have a 4-point loading and we have to put dead center of the specimen. The loading nose are not where the strain gauge is going to go. But the positioning of that gauge on the anvils is very critical. Without it, you can just load the specimen, make sure it's fairly even on both sides, and then you can run the test. With a deflectometer that actually fits in the actual jig, you just go underneath there. And most deflectometers are strain gauge based. So sometimes it's just a question of what are you trying to do, what you're trying to accomplish. Can you use strain gauge? Yes. Sometimes it's just a cost saving situation where you just want to repeat so many tests.
And if you were going to use strain gauges on these flexural tests, it looks like you would stay in kind of the little bit larger size gauge.
Yes. Yeah, because you really want to measure, especially with composite testing. One of the issues you're going to have, if you have a unidirectional fabric, then it's you're going to be measuring that fiber in that direction, so that you put it, dead center of that coupon, and the coupon's only 1/2 inch wide, then you're doing good. But if you have a lot of fabric orientation in that fabric, like a plus minus 45, a 0.90 in there, a combination of all these, and then at that point, the location of that gauge and the size of that gauge is critical. You want to capture as much of that strain field as possible in that area. So if you go too small, you might miss it. You can't really go too big unless you go outside the specimen. So sometimes it's a little bit better to go in a 250. And you'll see in some cases pretty long and narrow 500 size gauge installed in flexural.
Cool.
I think that covers pretty much all the kind of the category.
Yeah, so we covered tension, fatigue, shear, compression, flexural.
There's maybe one item that we didn't touch a whole lot, which is sandwich composite testing, where you have skins of composite, could be glass, carbon, and then you have a core material, and then another
like
skin.
a honeycomb kind of core.
It could be an honeycomb, could be foam, could be balsa wood, could be all kinds of.
Okay.
Basically, what you're trying to do with core material is basically, it's a geometry thing. You're trying to remove the weight in the middle, which usually doesn't see a ton of stress, and put it towards the skin, which is actually going to be loaded. That's where I believe, in a lot of cases, it's really critical to have some ways to measure the skin movement, because you can rely on, at that point, on the displacement of the crosshead. Because you're compressing a foam core or a honeycomb core, and it will have different behavior than the skin would do. And also, it's very important when let's say you do an edge-wide testing, like a C364, where you're going to basically put the material on its side. You're going to be pushing down on the two skins and the core. But the material, let's say it's a 4x4 size specimen, it's only 1/2 inch thick. There's a lot of buckling that could happen there. And not having gauges on that coupon, you might totally either underestimate the modulus or overestimate the modulus, depending which, if you're on the tension side or the compressive side, if the skins are debonding from the core. So these are type tests where, strain gauges are not only valuable, they're necessary. And again, we're talking about a 250 type size gauges, 350 ohm resistance minimum. And the reason for the resistance and anything really composite or plastic, there's a chance, because it's insulating materials, that the actual gauge could heat up. Having a 350 ohm help reduce some of that.
Yep.
Allows you to have a higher excitation a little bit in some cases if you need it. You try to be within between 1 and maximum probably 5 volt, but I would probably say 1 to half volt is probably where you're going to be. So in a lot of cases using 120 ohm, it's totally not recommended, because then you have a heating problem, and then you got thermal output and things that you don't need in your testing.
Okay. Well, I think we pretty well covered it, Bruno. If customers would like to find out more information and talk to you specifically about composites testing, how would they reach you?
Well, there's 2 easy ways to reach us. You can go on our website, and there's a section that contact us where we have our phone number, which is 919-569-9922. Or you can also do info@BCom Testing. We'll come here and we'll answer your questions. We've been doing composite. I've been in the composite industry myself for 25 years now, and pretty much doing testing for the most part of that. So the strain gauging part of it is, as you use it and realize the importance of it, I think right now probably more than half of what we do is strain gauged. And we do all kinds of different tests, for mechanical purposes. But the importance to me is, how good is your data? It's usually based on how you testing it. And the ASTM is really good, Bible, if you want to, as far as how you're going to run the test. But there's a little bit of know-how, which gauge sometimes perform better than others in certain situations. And that takes a few years to get around to it.
Okay. Well, great. Well, Bruno, I appreciate you taking the time this morning to talk about the composites testing and the typical test setups, and a little bit about the gauges and how all that intermixes together. Looking forward to seeing you in a few weeks at the strain gauge class for composites and plastics and helping us out.
That sounds good. I'm looking forward to it. Hope anybody that's listening to this is going to be able to attend, and we're looking forward to seeing you.
Okay, great. Thank you.